Two bodies, close enough to feel each other's heartbeat, in the dark, with no one else around for miles. No words yet, just breath and warmth and a closeness that isn't about hunting or fire or staying alive until morning. Here's the strange part. Biologically, this moment should not be quiet. It should be loud. In almost every other primate on Earth, a female's body broadcasts fertility to anyone nearby. A swelling, a color change, a scent carried on the wind. A baboon can't hide it. A chimpanzee can't hide it. But somewhere in our own lineage, that broadcast got switched off, and no one knows exactly when or fully agrees on why. So the two people in the dark have no idea, on a purely biological level, whether this moment can create a child or not. Neither does anyone watching them. That single missing piece of information may be one of the strangest things that ever happened to a mammal, and it may be one of the reasons you're here at all. The kiss, the closeness, the bond that was supposed to be simple biology turns out to hide a puzzle. Let's get into it. Start with a number that sounds small until you sit with it. Long-term pair bonding, two individuals staying together well beyond a single mating, shows up in only a small fraction of mammal species. By some estimates, as low as 3 to 5%. Most mammals don't do this. They mate and then they go their separate ways. Our closest living relatives don't do it either. Chimpanzees and bonobos, the two species that share the most DNA with us, both live in groups where mating is largely promiscuous. Multiple partners, no lasting exclusive bond, no single figure raising offspring alongside one committed partner for years at a time. That's the baseline we come from. And yet, at some point, something in the human lineage bent toward the opposite. Long-term bonding, pair-based family structures, partners who stay close for years, sometimes for life. Among primates, and honestly among mammals generally, that's the unusual choice, not the obvious one. So the question isn't just why humans fall in love, it's why a species descended from promiscuous, group-mating apes would evolve toward pair bonding at all, when almost none of our relatives ever did. Here's where it gets stranger. The clue isn't in our behavior. It's in something our bodies stopped doing, quietly, without any of us ever noticing it happen. Every other female primate you can name gives some kind of signal at ovulation. Visual swelling in chimpanzees and baboons, shifts in scent that males can detect. In some species, changes in behavior that make fertility obvious to everyone nearby. It's honest advertising. This is the window, and every male in range can read it. Human females don't do this. Ovulation in humans is concealed, hidden well enough that even the woman herself can't reliably feel the exact day it happens without tracking her own cycle. Researchers call it concealed ovulation, or the loss of estrus. And it is not just rare, it may be closer to unique among group-living primates. That should be a disaster for a species trying to reproduce. Losing the signal should mean losing the ability to time mating around fertility at all. So why would evolution delete the one signal a species needs most? There are competing explanations, and researchers are still arguing about which one, if any, gets it fully right. One long-standing idea is that hiding ovulation may have encouraged males to stick around and mate repeatedly across the whole cycle, rather than showing up only during a brief fertile window, which could have nudged behavior towards sustained partnership instead of a single opportunistic encounter. Other researchers have proposed the opposite angle entirely, that concealment evolved between females competing with each other, not as a signal aimed at males at all. Neither theory has fully won the argument, but look at what all of them share. Every explanation on the table assumes the same starting problem. Once you can't read fertility on site, staying close all the time stops being optional. It may become the only strategy left that still works. That single missing signal may be the quiet biological nudge behind one of the strangest habits in the entire animal kingdom. The closeness that had nothing to do with the fertile window at all, because nobody could see the fertile window anymore. And once closeness stops being seasonal and starts being constant, something else has to hold two people together in between. That's where the story gets stranger, and a lot older than you'd guess. Here's the twist almost nobody expects. New research on the evolutionary origins of kissing, published in 2025, traced the behavior back roughly 21.5 to 16.9 million years, to the shared ancestor of humans and the other great apes, long before humans existed, long before language existed. The same researchers found evidence suggesting Neanderthals likely kissed too, which raises the obvious question. If a kiss doesn't feed anyone and doesn't obviously help anyone survive, why would it be one of the oldest intimate behaviors we can trace? The leading explanation researchers have proposed isn't romantic at all. It's called the grooming hypothesis, and it suggests kissing may be the surviving final stage of a much older grooming ritual. The moment a groomer's lips would linger against skin or fur to catch the last bit of debris or a parasite. As body hair thinned out over the course of human evolution, that hygienic purpose faded. But the final gesture of the grooming bout, lips meeting skin, may have simply stuck around, stripped of its original job and repurposed as something else: connection. So the kiss you'd call romantic may not have been invented for romance at all. It may be a vestige, a leftover ritual from a hairier ancestor's hygiene routine that outlived the reason it existed and got reassigned to something far more emotional. And here's the part that should genuinely unsettle you a little. It isn't even universal. A landmark 2015 study surveyed 168 cultures around the world and found romantic mouth-to-mouth kissing confirmed in less than half of them. Entire societies in sub-Saharan Africa, New Guinea, and parts of the Amazon showed no evidence of it at all, and some described their first encounter with it, when European travelers arrived, as outright unpleasant. So the kiss isn't some universal human instinct hardwired into every culture on Earth. It's older than humanity, and yet somehow it's optional. Biology hid the fertile window. An ancient grooming habit turned into something else entirely. But none of this proves ancient people actually felt what we'd recognize as love, or ever meant to leave evidence of it. For that, you need something no theory can provide. You need a body in the ground that never let go. Theories about hormones and mating systems can only take you so far. At some point, you want proof that ancient people actually felt this, not just that their bodies were built for it. Two burials thousands of years apart may be as close as archaeology gets to an answer. The first is a small carved stone, roughly 11,000 years old, found in a cave near Bethlehem called Ein Sokri. Using the natural curve of a calcite cobble, someone shaped two intertwined figures, faceless, arms wrapped around each other, in what researchers describe as the oldest known sculptural depiction of two people embracing. It now sits in the British Museum. Whoever carved it left no name, no story, nothing but the shape of two bodies, who clearly meant something to whoever picked up that stone and started carving. The second is not a carving. It's the real thing. In 2007, archaeologists near Mantua, Italy, uncovered a Neolithic double burial, roughly 6,000 years old, containing two young skeletons, likely a male and a female, positioned face-to-face with their arms around each other, frozen in what looks unmistakably like an embrace. Of the 30 graves excavated at that site, theirs was the only double burial. Someone made a deliberate choice to bury these two people exactly like that, together, holding on, and then left them that way for 6,000 years. Neither of these is proof of romantic love, the way we define it today. Researchers are careful about that, and so should we be. But they are proof of something. Someone, thousands of years apart, in different parts of the world, looked at two bodies wrapped around each other, and decided that image was worth carving in stone, or worth preserving in the ground exactly as it was found. A hidden fertile window, a borrowed grooming ritual, and now two burials that suggest the closeness wasn't just biology working as intended. Somebody noticed it. Somebody wanted it remembered. So which one of these actually explains why humans bond the way we do? The honest answer is that none of them work alone. Here's what ties all of it together, and it's happening inside a body right now, not in a cave or a museum case. Much of what researchers know about the chemistry of bonding comes from an unlikely source: small rodents called prairie voles. Unlike almost every other vole species, prairie voles form lasting pair bonds, and scientists studying them found that two hormones, oxytocin and vasopressin, appear to drive that attachment at the molecular level, with oxytocin playing a larger role in females and vasopressin in males. Closely related vole species that don't pair up simply have fewer receptors for these same chemicals in the brain regions that matter. Humans release oxytocin too, during touch, during closeness, during exactly the kind of moment this episode opened with. It's not proof that human love works identically to a vole's, and researchers are careful not to overclaim that leap. But it suggests the feeling of attachment isn't just a story we tell ourselves after the fact. It may be built into the same category of chemistry that binds a small rodent to a single mate for life. So layer it together. A body that stopped advertising its own fertility, which may have made constant closeness the only strategy left that still worked. A kiss inherited from an ancestor grooming ritual millions of years older than our species, repurposed into something we now call affection. Two burials, thousands of years apart, where someone chose to freeze an embrace in stone or in soil rather than let it disappear. And underneath all of it, a hormone system that doesn't care whether you understand any of the history. It just quietly does its job anyway. None of it was designed, and none of it was inevitable. It was assembled, piece by piece, out of a hidden signal, a repurposed habit, and a chemical reward system older than human memory itself. The two people in the dark at the start of this video, in that moment, weren't just running on instinct they were born knowing. They were running on millions of years of accumulated accidents that happened to work, being lived out again, one more time, by two people who had absolutely no idea any of this was happening underneath them. That's not a smaller story than romance. It might be a stranger one. If you enjoyed uncovering the real history hiding in the moments we usually call instinct, subscribe to Ancient Actually. Every week, we separate myth from evidence and reveal the remarkable ways ancient people survived and connected in a world far harsher than most of us can imagine. Because history isn't just about what happened, it's about discovering why it happened and what it can still teach us today.